Hello everyone, now we are going to discuss the next topic, that is uniform velocity motion. Basically, we have seen the follower and its characteristics, in which we have seen that the mean velocity of the follower, okay, and the T naught is the out stroke time, TR is the return stroke time, like that. So we will discuss the uniform velocity motions. That means the displacement curve will be linear. See, we all know that the V is equal to dx upon dt. We all know that. Okay. So if the velocity is constant, if the velocity is constant, that means x would be linear. You can say that the it would be Vt plus C. So if V is constant, C is also constant. So that means the displacement will be linear. Okay. So the displacement will be, or the displacement curve will be linear. Will be linear. Is it clear to everyone? Because the velocity is constant. Uniform means constant velocity. So we can say that the displacement is a linear curve. You can see here. Okay, it is a straight line. So we will calculate the mean velocity. Okay, and we will see the diagram of displacement and velocity and accelerations in the uniform velocity motion. So see here, what is the velocity of VO? VO, this means when the displacement will be, or when you can say when the follower is going rise. Okay, that means the out stroke time would be considered as T naught. Okay, so V naught is basically V naught during out stroke. What would be the velocity? This is V naught maximum. The velocity is constant, so it doesn't matter the maximum or minimum would be same because the velocity is constant. So V naught mean, and what is the mean velocity during the out stroke? So it would be, we already calculated in the last video, omega s upon theta naught. You can see in the follower and its characteristics we have calculated the mean velocity of follower. Okay, that would comes out to be omega s upon theta naught, where theta naught is the out stroke angle of the cam in radian. Okay, and omega is the angular velocity. This is the angular velocity of cam. This is the angular velocity of cam. Okay, and as is the displacement, or you can say sometimes it is called it as a stroke of follower. Okay, so this would be omega s upon theta naught as mean velocity of follower, because the velocity is uniform in this case. Okay, and what would be the velocity during return stroke? So Vr is equal to Vr. That means Vr means at any point. Okay, at any situations, at any condition, and at any angle of the cam, the velocity of the follower during the return stroke, that would be Vr is equal to Vr maximum. That would be the same value as mean. Okay, so that would be omega s upon theta return stroke, and theta r is the return stroke of cam. Okay, and let me draw the diagram. So this is the case we are considering of, this is the case of uniform velocity motion. Okay, so during the uniform velocity motions we have seen that the displacement curve is linear. We have seen that. Okay, the displacement curve is linear means it would be like that. Initially it will start from 0. See, it is here, and it will be constant during 12, and again it becomes 0 following the linear path, can see here, this is during outstroke, this is during return stroke, and this is the conditions when the follower remain constant, that means dwell. Okay, so what is dwell? Basically, if I'm talking about the angle of dwell, we have seen that when the follower remain stationary, so the angle turned by the cam would be considered as angle of cam. Okay, so angle turned by the cam during the stationary condition of the follower is the dwell, angle of dwell. Okay, so this is the dwell conditions. Okay, so this is the curve displacement s, and this is theta. Okay, and this is 2 pi, complete angle is 2 pi, because the follower reaches to the initial conditions during the one complete rotation of the cam. Okay, so let me draw the curve of the velocity. You just have to remember that the curve is linear during the uniform velocity motion. Okay, the displacement curve is linear during the uniform velocity motion. Displacement curve, displacement curve is linear. You can write here that it is linear. Okay, and let me draw the curve of velocity. So this is the displacement, and this is the curve of velocity, which is equal to what? Omega s upon theta naught. Okay, which is equal to omega s upon theta naught, which is also equal to the maximum velocity, mean velocity at any point, at any condition, the velocity remains same. So suddenly it will rise, suddenly the velocity will increase within a short durations like that, and it is remain constant. And for the next situation, the speed will decrease drastically and it becomes zero during the angle of dwell. This is the dwell conditions. Okay, so when the follower rises, or you can say that during the outstroke time, the velocity of the follower increases suddenly for during the short period of time. Okay, and it will remain constant because the velocity is constant. Remember that it will increase from 0 to the maximum value, but for the very short period of time. So this is the actual diagram I'm just drawing here. Okay, but remember that the velocity remain constant, and after as the this is the you can say this is the outstroke condition, this is the outstroke condition, and after the outstroke, the angle of dwell, that means the dwell in the dwell conditions, during the dwell conditions, the velocity becomes zero. Okay, because the follower is not going to move, so it will having the velocity zero during the angle of dwell. Okay, and after that, suddenly it will decrease drastically in the negative direction, and it becomes zero as the cycle is completed. Okay, the cycle is of 2 pi, and during this time the velocity is omega s upon theta naught, and during this time, during the return stroke time, during the return stroke, the speed is omega s upon theta r. Okay, this is the return stroke conditions. Is it clear? So if the velocity is constant, we all know that if the velocity is constant, the acceleration would be what? Dv upon dt. So that means it is zero because the velocity is constant. So if the velocity is constant, acceleration becomes zero. So if you want to draw the diagram of the acceleration during the uniform velocity motion, it would be like that. It would be like that. As the speed increases drastically, okay, for the short period of time, so the acceleration will increase for that period of time, and it becomes 0 when the speed becomes constant. So it would be like that. It would be like that. Now you are able to understand the situation. See why it is in negative direction. See, here you can see that the velocity increases. Here you can see during the outstroke starting condition, the velocity increases. So that means acceleration would be there. Okay, this is acceleration. Okay, but as the outstroke completed, the velocity decreases to 0. Velocity decreases to 0. That means there will be a retardation. Okay, there will be a retardation because the velocity becomes 0. Okay, and again in this condition you can see that the velocity decreases during the return stroke for the short period of time. So again there will be a retardation, but as the cycle is completed, the it will increase up to 0. So there will be an acceleration. Okay, and the one more important thing, this is the diagram of acceleration basically. Okay, you can match this to this condition, match this to this condition, like that, like that. So what is the use of uniform velocity motion when we use that? So basically generally in the examinations they will ask you that which type of motion is going to use very low speed applications. So we will use uniform velocity motions, uniform velocity motions of the follower. Okay, so the use you can see here that used for very low speed, very low speed. Okay, so I hope you will understand these whole conditions. Okay, remember that the formula, this is the formula which is very important. Okay, and this is the condition you must remember where we use uniform velocity motions. Okay, and for the basic understanding I have drawn the diagram. You can see that the displacement curve is linear, velocity is constant, and acceleration is 0. Okay, this is just because of the simple equations of motions. Okay, so thank you.